In today's video, we begin to discover slope-intercept form. This is the form that we will rely upon almost exclusively from this point forward to graph linear equations. It's named accordingly because within slope-intercept form, it gives us two pieces of information. It gives us the slope, as we know, is represented by m, and it gives us, in this case, the y-intercept. We're familiar with intercepts, but this one gives us the y-intercept, and we're going to begin to recognize that intercept with the variable b in the formula y equals mx plus b. So b represents our y-intercept. Now we know about intercepts because that's how we have been graphing lines as efficiently as possible up until this point. To solve for the x-intercept, we substitute 0 in for y. To find the x value, and vice versa. To solve for the y-intercept, we substitute 0 in for x to find the y value, and we plot those 2 points accordingly on their respective axes, and then we graph the line. But if we can work with an equation and convert it into slope-intercept form, specifically y equals mx plus b, then we'll be able to graph directly from this equation. We're not going to have to solve for the intercepts to plot those points, only to graph the line. So we know that the slope, m, in the formula y equals mx plus b, is our vertical rise over our horizontal run. We've become very familiar with counting rise and run as one way of finding slope. And we know the y-intercept, in this case the b in our formula, is nothing more than the point at which the line crosses the y-axis. So this is going to be real helpful because once we get these equations in slope-intercept form, we'll be able to start or use the y-intercept as our starting point, plotting that point on the y-axis where it belongs appropriately, and then using the rise and run of our slope to count up or down or right or left, and to find other points on the line. And we've had practice doing that already. So what we need to do is to begin to practice how to convert an equation into slope-intercept form. And the way that we're going to do that is by following the process of simplify, isolate, solve, but focusing specifically on the isolate and the solving aspects. So the isolate in this case is going to require us to get the term in our equation with y all by itself to one side of the equation. And the solving is going to require us, if there's a coefficient that y is being multiplied by, to use the inverse operation of division to get the equation down to simply y equals, not some coefficient times y equals. So let's begin the process. If I start with this first equation, I can see on the left-hand side y is not isolated. It has 5 being added to it. So we simply use inverse operations. In this case, we're going to undo the plus 5 by subtracting 5 on both sides. And that's going to allow us to get the y term isolated to the left. Now, more importantly, what it's going to do is it's going to allow the x term and the constant, and that's what this minus 5 jumping over to the right-hand side is going to be considered as, a constant. It's going to allow those to be separated from the y term altogether. Now, the important thing to recognize in this process is these are not like terms. 4x is a variable term, minus 5 is a constant term, so we're going to resist any temptation to try to combine those together. All we can do with them is to form an expression with the 4x and the minus 5, and flowing in the order that y equals mx plus b asks us to do. So you notice this says y equals, there's my x term playing the role of mx. And I know that the formula says plus b, but when it says minus 5 here, that's really just the equivalent of saying plus a negative 5. So we'll get in the habit of recognizing that. So I've taken care of the isolating, and since there's no coefficient, or I shouldn't say that, since the coefficient of y is 1, there's no need to divide this equation further. So we have our equation in slope-intercept form in that one move of isolating. So the equation is y equals 4x minus 5. So in recognizing that this is in slope-intercept form, we want to remember now that the number that x is multiplied by plays the role of m. So our m in this case, our slope is 4. And the number that is being added, or in this case subtracted, from the x term is going to play the role of our y-intercept. So the b in this case is -5. And then we're done. So let's try this on one more equation, and I will then leave you with doing 2 more on your own following the process. So the first step, once again, as we look at this equation, is to isolate that term with y. So the way we will do that is to begin by undoing the -2x by adding 2x to both sides. And that is going to get our y term isolated, 3y equals. And once again, do not be tempted to combine these two terms together. 12 is a constant, 2x is a variable term. All we do want to do is to align these in the proper order. So we want the x term 2x to come before the 12, which we want to recognize as positive, so we'll say plus 12. And this is beginning to take on the flow of y equals mx plus b. But we're not done in this case because we have to undo the y being multiplied by its coefficient of 3. So we will have to divide everything in the equation by 3. In doing so, the 3's will cancel. I'll get my y fully isolated. And in the case here where it says 2x over 3, what we're going to do is to extract the 2 and the 3, and we're going to make that 2/3 as a fraction, which plays the coefficient of x. And then in the case of the positive 12 over 3, I'm going to simplify that. And that's simply going to become plus 4. So we have now, through simplifying, or not through simplifying, but through isolating and solving, we have gotten our equation into slope-intercept form, which in this case would be y equals, well, my m here is 2/3 x plus 4. So if we go back and recognize the respective pieces in their appropriate parts, then we know that the m is what x is multiplied by, so that's the 2/3. And the b is what's added or subtracted, in this case added, so our b is positive 4. So that is slope-intercept form reviewed through 2 examples. I'll ask you to repeat the process with the next 2 examples, and we will come back to class and discuss and practice this process further.